Yeah. Thanks for joining the session. We are going to start the session now, the webinar that we planned, the Docker in production. So yeah, so let me give a quick overview about Newt Global. As before we start the session, we are a leader in DevOps transformation, test automation, and cloud enablement. So we have implemented end-to-end DevOps tool chains for some of the Fortune 50 companies with global delivery capability for initial location, and premium level partnerships with the product companies. So reusable frameworks and libraries that we have built internally, which helps our customers to fasten their delivery. So this is all about Newt Global. Yeah. So here are the speakers profile for today. We have Venkat Tirunalai, DevOps practice leader at Newt Global. So Venkat is a practice leader, and his area of expertise includes DevOps and cloud. He consults some Fortune 100 companies and has around 16 years of experience in the industry. At Newt Global, he's responsible for building the global pre-sales and consulting and delivery teams. And we also have Jay Karthi, and he's an AWS solution specialist at Newt Global. So his area of expertise includes DevOps, and as well as AWS. So he has more than 6 years of experience and have worked not less than 24 projects with smooth delivery for about 24 enterprise customers. So with this, let me hand it over to Venkat.
Yes, thanks a lot, Satish, for the introduction. Hi, everybody. This is Venkat from Newt Global. Today, just to introduce a little bit about what Newt Global does. We are basically the DevOps company, and we do we take DevOps to the market in three kind of levels. One is our onboarding zone, where basically we help companies implement the DevOps pipeline. The other is the engineering zone, where we do a lot of build orchestration, build automation, infrastructure automation, Dockerize applications, take Docker to production. And then we have got a re-architecture zone, which is around for microservices, where we kind of re-architect applications as microservices and domain-based design. So that's the overall snapshot of the organization. Yeah, so coming, and in fact, in the previous webinar, for those who have attended in the previous session, so we talked about the Docker basics, we talked about various elements of Docker, but bulk of the demo and what we showed was all, it was like a developer doing it on his machine, right? And you could do a lot of commands. You could do a Docker run command, and you could do a Docker start. A lot of these commands you could explore Docker, but in the real world scenario, when you are basically kind of having a lot of microservices, or you're Dockerizing a lot of applications and putting them in in production, there are, honestly speaking, a lot of considerations, and I'm going to cover 6 high-level buckets so that you are able to kind of to give you a flavor of the overall thing. So given a 1 hour kind of duration, it may not be viable to cover each and every topic in detail. So I will touch upon the 6 areas that I believe are the important ones, and I'll tell you what we are going to cover in this session. Okay. So one thing is, basically we live in a fast-paced world, and we need to do CI/CD and quick deployments, and it's very important to have orchestration tools, like Docker Swarm or Kubernetes, which are the the tools of choice for orchestrating Docker and helping them scale in production. And in fact, we'll be touching upon Swarm and Kubernetes as a detailed demo in this 1 hour session. And the other areas that we need to be aware of is the the resource management, and how do you ensure that the containers have the right amount of resources, or we are able to kind of have a proper monitoring in place where you're able to identify the traffic spike and able to kind of allocate the allocate containers on the fly. Okay. The backup management, right? Like your capacity to handle backups and backing up your entire system. It's an important part of your entire application lifecycle management. Okay. And of course, when you're talking about moving the containers, as we saw in the previous seminar as well, as compared to a virtual machine, Docker containers have a higher surface of attack. It's not that Docker is less secure, but it has a much higher surface of attack as compared to that of a VM. Therefore, security becomes very important. And in fact, one of the things, especially if you're trying to scale Docker across multiple hosts, you end up, exposing the ports, and and that can lead to a lot of vulnerabilities in your application. In fact, in the demo, we'll talk about how we can address this in Docker Swarm, and how using a third-party tool called Flannel in Kubernetes we'll be able to address this. Another two other important last but not the least areas are monitoring, understanding the the traffic patterns, managing the uptime, having monitoring tools in place to monitor your containers, and image and storage management. And these are a couple of other considerations that you need to have while you're moving Docker to production. Okay. Yes. Yeah. So at this point, I would like to I would want to give you, as I mentioned, we'll be covering the orchestration tools Swarm and Kubernetes in this session, and we'll also talk about how we can achieve port masking in production, which is a very important thing if you want to run your applications in production. So these are the two considerations that we are going to have, and with this, I would like to hand over to my colleague Jay Karthi, who is who's going to walk you through the entire session. Okay. So yeah, so I'll be so Jay Karthi, I'll be passing the control over to you now. Show.
Hi, this is Jaikati here. I guess more of into using Docker for production level setups. So we will be mostly considering here on Docker. So we will be using more or less using Docker for production level setups, where we can get virtualized ports, and we will be getting more encryption security at the high level. So we are getting familiarized with Docker and how Docker becomes resource utilized, and it gives a full worth for the money what is being spent, and how Docker can be worth using and solving a problem that we normally face with the high availability and failover setup. How a downtime can be reduced, how this 99.9% and 100% downtime can be brought into a production level setup. So this is all about Docker. So these points what we discuss here is all basic, and it comes to Docker. So actually Docker goes in way too high. Docker comes with a native support. Docker containers are huge and widely popular for the term that is being used. So some of the keywords that we are going to go in detail is like some Docker Compose, Docker Machine, Docker Nodes, CLI containers. So Docker containers, as it is like a image that comes in like a cloud image, or it could be a resource utilized but to the minimal level. So minimal level in the sense it's not going to be occupy the entire server capacity, but it's only going to take up to the limit where an app really needs. So considering our primitive or X server setups, what we were doing for a server to deploy an application, it is going to be taking up the less resource intensive. When it is, there was a time when we were using AWS servers for deploying applications with heavy amount of resource, say 8 GB RAMs and 30 GB, 100 GB storage space, and then still we weren't able to achieve high availability, and failover was a nightmare for most of the managers. Most of the project managers were having it as a high-end problem, and then the security connection between node to node were an issue all the time. So all the questions that comes into mind can be answered with the word Docker. Why? Because the Docker comes in with less resource intensive. It is quicker than a normal server image that is being offered by AWS itself, and it is like so quick that it is less than 10 seconds to launch and then connected, and it's going to be cluster manager who is going to control the nodes, which we call as like Docker containers. So why this is very important? In the sense, every time a sanity check is going to be performed on the random level of Docker containers which are available, which are going to be serving every user request. So why this is very important? In the sense, anytime a server is not going to respond to an incoming request, it becomes a tragedy. Every time we have to manually identify that a server is not performing, it is down, server burst out, a T2 instance has gone down, and then a service engineer is actually looking into the server. All these are going to be like a troublemakers for us. So Docker is all about the high and reliable service to the end users. It's all about failover and high availability. It's a sequential execution of steps that we use for configurations. We just, in the previous webinar, we also saw about building up a Docker image using Docker builds. So one time this is done, what happens? Next step, it is going to be only like a versioning of the images that is going to be used for application deployment. So every time the Docker file grows, it is only going to indicate that the amount of resource which is utilized for a container will be slightly growing up, but still it is within our hands. It can always be brought down, and it can always be optimized at our own convenience. What Docker containers offer for deployments and for testing and dev team is like it is going to give them a good R&D time, and they can be trustworthy, and they can always do all their R&D works within the cheapest resource that is available. I mean, like one AC2 instance can hold up to like 30 Docker containers at max. With the limited resource availability, all sort of POC R&D works becomes possible, right? So the Docker containers are highly specialized for the porting, how much cross-platform they are available and how they can be handled. So we come out with Docker management on the clustering basis. So preview of Docker containers on the earlier stage was like they were good performing, but there isn't a manager to handle it. So that's what brings in the concept of Docker containers. Docker Swarm is the Docker native clustering system, which is going to be controlling the pool of Docker hosts, and to maintain it look like a single virtual host. It will be actually one incoming request or one number of requests, one set of requests, any number that comes in will be directly faced by the manager. So manager, what he actually does is like he is going to deviate all his incoming requests beyond his limit. So that's when the worker nodes who are connected to the manager will be popping out with all the possible solutions by setting up or getting a service updated in their SIM, their available resource, and then giving out their managers with the request being responded. So it's all about rolling updates. So versioned containers are the picture that we are actually planning to show up here. Whenever we actually wanted to deploy something, we wanted to create resource as and when immediately required, but it's not coming for free. We wanted to spend some bucks for it, but most limited amount of spending and the more amount of resource utilization is what we focus. So rolling updates, and with security in mind, Docker cluster management becomes the vital for application stacks, how the services are being deployed and how the service level is going to be updated. Some of the preliminary CLI commands that we use for a Docker Swarm cluster on a CLI basis, we will be using swarm, init, join, create, inspect, some preliminary levels, but where it becomes higher is like at the last three: service scale, service process, service update. So why this becomes an important role is like service scale is going to scale and create replicas of the existing or a newly created service. So that is the key point in adding up to the resource utilized. Once a service has been deployed, we always inspect and see whether the service that is up and running is active, whether the service is being decided and given some value worth it. Everything, is it running, is it stopped, or any other issue happening, any sanity check to be done. Everything can be defined or can be seen at the early stage with the CLI command, but that would be more beyond the DevOps side, what we focus on DevOps. So what we plan here is like we are going to show up with the Docker Swarm on a Docker rolling update with Docker Swarm mode using Terraform in AWS environment. So we have planned out to show you with a single AWS cluster management with one single manager taking 2 nodes. We can see here, I just have a configured Docker Swarm setup that comes in, and I am building it for you guys. So as you can see, once the build has started, it just comes out with, like the disk space that is available, what are all the preliminary steps and configuration files that has to be pulled in. Everything is going to be fetched from the repo. So once all these are done, it keeps on running, and then this configuration happens to take like the VPC, the security group, whatever that is being launched, everything will be showing up. So we just getting a Swarm master created and it's initializing, and we will be up and running in a short while. So, and the Swarm manager, which would be executing the commands which we will be showing up to you here, is like it's going to give up with the init, and then it is going to use the join command. So once the join command comes in, the first thing that we are going to obtain from a manager will be the basic security token. So it's all about the security. So AWS allows us to connect only through private keys. So what we do is like we push in the private key into the environment and we just got connected, as you can see. So once the server has been created with the configuration file, it just starts up with the update and upgrade, and all the commands gets executed in progress. And then we see like we are using a Ubuntu 16.04, and it comes out with a huge amount of update and upgrades. So we just have to wait for some time. So once happens to be like update upgrades are completed, it's all about configuring the Docker engine. The Docker engine 1.12 is what we use and heavily supported for Docker Swarm on the cluster management level. So we got the Docker Swarm token, and this is what we get just copied to a file, and this file will be transferred to the slave or the workers. So once they are available, they will be getting in. As you can see, it's pretty quick. Once the manager is up and running, you can see the slaves being created. We just refresh and see. Okay, 2 is up. Right. So we just got 1 and 2. We just got 1 and 2 here, and it's going on for a while. So the provisioning part, the private key that what we got here is like we are getting it dumped into the newly created managers along with the security token. So the security token will be used for making a communication with the master, and once they are up and running, we will be making a provisioning. Yeah, here we see the provisioning part has also started. So every successful provisioning means like a connection has been established. So slave 0 is started, and then once that is done, then it will be slave 2. So it all takes like less than a matter of time. So all this happens to be like within the Docker overlay. So it all happens with a secure network within the Docker swarm. So, and you could also see that it's a swarm group that has been created as a security group. So beyond AWS limit, we are also putting an additional layer of security on the top. So to make that the communication happening between the manager and the worker nodes are actually like secured. So that's a third level of security that we are offering here. So this is a join, and once this has been done, we'll start off with the termination. So we can see here that node is joined with as a worker. Okay, once I'm done with this, I will probably turn it off after a while. So I'm just using a Terraform destroyer. So it happens like it immediately turns off, and then it is going to kill the instances whatever has been launched here. So how quick this Docker setup up and running and down can be brought down, it all works with great grace, and it's quite easier for us to work on with Swarm. Now let's have a look at Kubernetes. Kubernetes we'll be using with the hash value. So it's all about the pods that is being used. We use pods on a high level for making a shared resource availability. It ensures co-location, and it is like schedule. It could be easily scheduled with the Zookeeper and other stuff. What are the resources that we are going to we are planning to use up here will be the volumes, IP or network, port space. It could be CPU or memory allocated to the pods that are being created. So it's all about making the stuff working and faster. So the labeled selectors are here to make the key value pairing, to make the paths easy to identify, and it can also be queried with selectors. It is vital where it comes to the deployment part. Like if it is going to be release oriented, then it should be a stable one, or it's a canary blazed or blue-green deployment, red-black. So all these things can be identified pretty much easier. So pods are again created on EC2, and then the resources are shared. Pods are working with Flannel network for communication that we do here. We can see the service automate as similar to Docker Swarm cluster management. It's all much quicker, and is no way at par or at above. They are equal one-on-one component opponents here. Let's see the demo with Kubernetes. I mean, like what we are going to see. Yeah. So the Docker Swarm is getting shut down here. So once done, we are working on with the Kubernetes setup happening. There we go. We just started the cluster setup. With AWS, we are just going on for a while. So the package that gets in would be the Kubernetes package, and it's extracted, and it's going to be working on with AWS credentials that we have to pass. And again, it comes with Flannel network. So whatever files that we need to be extracted for, say, let's say it's a Linux AMD 64, that we are placing it actually in the S3 bucket, and then we are getting it uploaded. So it comes with quite a lot of customization when it comes to Kubernetes. Either it's a VPC or a cluster, security group, IAM role, and also it comes with the service deployment as we promised. It is all about the Kibana and Grafana, all the service-oriented tools that we see here are getting deployed. We'll be getting a whole list at the end. So the master security group and many slave security groups are getting created. As we can see within the cluster, it's going to be the master and the worker nodes. Again, that's similar to one that we saw for Docker Swarm. But only difference is going to be the EC2s are going to contain pods instead of a container images. Here we just got the Kubernetes master started. And once the master is fully up and running, then we could be getting to know what the nodes that gets connected. So additionally, whatever we used here with Kubernetes comes in with the basic authentication of, again, the AWS configured part. So AWS offers private security and they are giving in the private key for our communication. So we are putting in our encryption, a third level of encryption that will be like Flannel and HCD. HCD, we are using it for service exposure between the master and the slaves. And again, it's going to be for the worker nodes that are going to be communicating with the master. Suppose I'm going to delete one of them. Let's see what happens. It always creates back because the sanity check always just gets started. So Swarm is down, totally down. We just deleted everything. And so it's easy to set up and easy to kill any. So Kubernetes part, we just have to see if it is high availability is really working or not. I'm just waiting for the initialization to complete to a limit, and then let me try deleting one and see if it really works. So the master is up and running. We have to wait for the 2x2 checks to be cleared. And once it's all done, we will be getting in with the, like the cluster setup will be completed here with auto scaling. Of course, it takes a pretty much of amount of time for this config part.
Yes, in the meantime, if you have any questions, please post them in the questions window. We will try to address all the questions during the end of the session, QA session. Thank you.
I just have one part to be checking. That will be like you just have to delete one node and then see if it is really working up and running. So I'm just waiting for the master to be cleared with the 2x2 checks. Okay, so That's pretty much of time we've been waiting for. We have to just see if the master has achieved the 2 by 2 checks here. Yes, done. So let's try and delete one of the, like worker node from connection, and we'll say if just like the sanity check has been done. Right, and terminating this one now. Okay, so I just terminated one, and we just have to see it so it is up and running. We will also be checking out with the constantly that build has been successful, whether it is really come up and running, and what will be the result of the build. Okay, here we got, so it all has come up and running. We could see the control manager, scheduler, HCD, 0 and 1. So it's like a one master with 4 worker nodes, and we just deleted one, but still it come up with another one. And we got all the nodes registered to the master. So because like one we deleted in the initial stage, it just got 3 registered, and it was waiting for the 4th one to be coming up and running, and we just brought it back to running condition now. So, and we just registered it, and it's working now. The cluster validation succeeded. So here, these are the details of the services that have been deployed with Kubernetes, like Elasticsearch, Heapster, Kibana, KubeDNS, Kubernetes Dashboard, Grafana, InfluxDB, as we said, and the build is a success. So looking closer at the builds, what were happening, because we just terminated one, and it was like 3 in the running mode. So the sanity check for the cluster seems to have find only 3 worker nodes, which we could see here, and it actually like identifies that one of the node is actually like physically not present, and it can consider it to be like unhealthy. Even I have to actually do it in my own way. I have to stop or terminate one, but still the sanity check happens, and it actually happens to bring in one, and then it is getting it registered. That's a pretty cool way of getting connected with the worker, between worker and the master. So the highlight part here is like once Kubernetes finds everything to be under control and all the sanity checks of the 4 instances that has been found, it's all about the scaling part. So once the 4 nodes are up and running with the services that needs to be deployed, let's say Heapster, or it could be Kibana, Kubernetes, or Elasticsearch logging, whatever it is, it all happens through the flannel part. So we could always see and debug and diagnose these things from the server. Except for the master, we would not be making any connections with the pods or with the EC2s that are being up and running. So it's all about the communication only happens through flannel. We don't really have a communication with the EC2s, which are under like worker nodes. So once the cluster validation is successful, only then the cluster services are going to be shown up. So if there is going to be a discrepancy here, if there is one of the nodes are not active, whether it should be 4 but it's only 3, then again this validation part continues here. As we can see, there was like one node, one worker node I just terminated even during the initializing phase itself. It just brought us with the time consumption, and it brought that one node into active state, and then only it went for registry, and then it found 4 nodes, then it goes on with active working state. It's not only about the initializing phase, But even in production, if one of the EC2 goes out busted, or if it is found to be unhealthy, then immediately another EC2 will be launched and connected, and then the busted one will be found as sanity check invalid, and it will be removed. Removed in the sense, in AWS terms, it will be terminated. So this all looks like pretty cool. So where we are with the Kubernetes part here is like as we spoke, it's all about the volumes and IP in our network sports, IP or network sharing, port space, CPU or memory allocation. As we can see, the services that are deployed with the master goes on with the worker nodes. The way we find a key difference between a worker and the services will be based on the key values that we are going to be using here. It helps us really with the searching part, and it's very vital when we are doing it with respect to the canary deployments or stable release, the versions that are going to be shown up here. I could walk you through the job configurations. So for Kubernetes part, we would be looking in more detail how we were doing it. Every time we just have to delete the workspace and get it up a fresh package, and that's how we maintain a clean slate environment. So for that purpose, we are getting up all the environment variables, right from injecting an environment variable, whatever components that we need, we are bringing it in here. We are pulling out every cluster cube setup, and then we are using a shell command to execute the script that we brought, and then we are pulling in all the cube related packages that is going to be made into execution. So that's for Kubernetes. And for Docker Swarm, we are making an execution with respect to, like, I'll also show you through, this is happening to the CloudFormation type, that is like Terraform. Something different between a Terraform and a CloudFormation would be like the Terraform would be retaining and refreshing the state every time it is going to be executed in parallel. So the most important walkthrough part will be here is like it continues to refresh every time we rerun the job, even if it is like already existing up to the part, the portion what is being existing in the state level and what is the update that we have pushed in will be executed, and the deployments with respect to the Docker in production, we could be pushing in more contents very quickly when it comes to using a Terraform type. So that makes it easy for us, and we are pulling in directly from the Git repo. I would probably like to walk you through the script, what we actually exactly doing here. So that might give an idea exactly what is being happening here. So we just make it like a provisioner part as AWS, and we pass in the access key, secret keys, which are supposed to be like confidential, and we are passing them only through the scripts, and we just keep them dynamic, so we don't pass them as it is. Once the provisioning part happens, then it is all about the resource that is going to be provisioned. Here I'm taking it as like Docker Swarm, so it's a Docker master actually. Swarm master is getting provisioned with the instance type, security groups, and the key pairs that are required. And every time the connection is made, it's actually becoming stable, and it happens with the SSH that makes the connection with the private key. So we don't really expose anything as it is. As you can see from the script here itself, whatever it is that comes even if it's a private key, normally we have to pass in the private key value, but we don't really do that here. We use it as a variable and we expose the contents from the variable. And then once this is done, it's all about the remote execution part, what we do for the Docker engine, how an EC2 is created and what are the parts that happens. So once that is done, it's all about the provisioning part. Provisioning part in the sense we come to know the Docker engine, the base for the Docker Swarm setup. Once the Docker engine is up and running, it's all about the part that is going to be making the connection. As I said in the slide previously, Docker Swarm is going to have the init. Once it is initialized, it's all about the join. We could always remind ourselves with the slide here, as we saw in the previous level. It's all about the swarm init, the join, and then it's a create. So once a create happens, service create is being it's a Redis that is required. And once that's done, it's all about the scaling part. Once service has been created, it's all about scaling. How many replicas do we really need to get it happening? Like we want a higher availability and failover setup, then we need to be cautious about defining and scaling it up. If it's an application, normally we put in 5 replicas for a service, and a Docker service going to be deployed with a replica 5 for a Redis service. Let's assume by the way, and Redis normally use 6379 port. So that will be in that case, one server cannot handle different ports of Redis. Though, but what we could do on a Swarm manager is we could retain the same port number, but it's going to be as a different encrypted way, and it will be like a port virtualization that is actually happening here. So once the scaling part is done, it's almost the scaling process. Docker service process are being checked here, and to see how many ways that process is going to be executed, and it shows clearly how it is running or it's exit. So once this is all done, if it's an existing service, then we really have to check in that whether the Docker services requires updates. Even if we come with the difference for a new version with the older version, what we could do is we could just simply go on with the Docker service update that pushes our newly created image and deployed to the service and then updated. So every version Docker container, compared to our previous webinar, we are coming in a bit closer to deploying it into service level. We come in for a webinar with the Docker version, and now these Docker versions are being deployed into services, and it goes on with the high stabilized level. So the manager with single architecture, we look at the managers and workers are going to be tightly coordinating with each other through the security token. The worker actually identifies the manager by the command. When we go in with the CLI, if you normally ask we have seen the previous webinar, it could be a sudo docker node ls. We just list, and then we find that the manager will be showing it as a leader. And it all comes the port that will be the manager using it for communication would be 2377. And the worker nodes will be using a different port, that will be 2376. So these are going to be used for a communication between the manager and the workers. Updating a service using hash values, what we have done here. Actually, we have used a service with a digest of SHA value that we have been used for a Docker pull and then push. That we have actually seen in our previous webinar, would like to see, and then it is all about pushing a Docker service. We have to parallelly push it with the SHA value. So why that really need is hash value is going to be the identity that what we are getting here deployed as a service is going to be a valid package, and it's a valid identified package that is being deployed as a service. So the basic comparison between Kubernetes and Docker Swarm, that's what we are trying to capture here. The more, the better. The more customizable version you want, you go for Kubernetes. The more easier and native based one, you go for Docker Swarm. Either way, it should be fine. But the more customized one, if it is a Kubernetes, then it is all about the security and encryption. It all comes with a price to pay. Docker Swarm comes in with the simplified setup. Kubernetes comes out with the heavy upload. All it is taking is like going to be with a huge price when it comes to production setup. When it is a Docker Swarm, I would neither say it is going to be cost effective and meagerly priced. It's equally important to say that Swarm is a competitor for Kubernetes, and they are going in like rivals, one-on-one. So the primary thing here is like either way we do the deployments of the service, either a service to the Docker container or a service automate happening to the pods that are used in a Kubernetes. Both these are being shown here on a demo for AWS. So AWS supports it both with the fine cluster management, and the primary thing is like when it comes to Kubernetes deployments, it has to be done in a more customized way. The way Docker Swarms brings in will be like very simplified for beginners, but advanced people who love to work with Docker and containers would always go for Kubernetes. Okay, any more questions you would like to see?
So I think the first question is what is the difference between Kubernetes and Docker Swarm? So would you like to take this, Jaikarthi?
Yeah, that's the point we were discussing here. Kubernetes and Docker Swarm. Docker Swarm is pretty much native, and it's quite easy for people to handle when it's a beginner level or an intermediate level. When it comes to Kubernetes, it's a high-end customizable version. People who like a lot of things about security and customization would definitely prefer Kubernetes. If you ask me, yes, I would go for Kubernetes. So otherwise, on the different side, if we speak technically, it would be Docker containers on the Docker Swarm, and it would be a pods in Kubernetes. If it's an overlay, it is going to be a flannel here. Yes.
So I think flannel is more for the masking of ports, which is not natively there in Kubernetes, but yeah, you can use that. Whereas Docker Swarm has that natively. That's an important. But overall, I agree with you. Kubernetes is a much more mature solution. If you look at as of date today, Kubernetes is much more scalable and much more proven solution for container orchestration. Okay. Moving on to the next question, it says, is there a separate plugin available, and what is so special about running through Jenkins? So not really, but end of the day, you need to have end-to-end orchestration, because end of the day, what is the use case for Docker, right? People no longer create one single WAR file and put it in production. They decompose that WAR file into microservices, and they deploy each microservice inside a Docker container, right? So that they are able to deploy and manage and play around with that services independently. Now you would end up having one application being split across to say 1,000 microservices or 2,000 microservices. Now in which case orchestrating all of that and having a proper CI/CD pipeline, it's important that you have a kind of a nice backend automation layer. So you can use Jenkins, but yeah, you can also use TeamCity or any other CI server, CD server. I'm sorry, CI/CD server. So to answer your question, there is nothing special about Jenkins. It's just a tool of choice for us. And is there a plugin available? Yes, Kubernetes and Swarm plugins are available in the Jenkins store. Okay. Um, so there's another question I don't quite understand what it means. Can you share how we can run on our end? And this question has been asked by Sri Krishna Parthasarthi. So can you elaborate what do you mean by this question? Okay, so you can type your what do you mean by this question into the questions platform, where I move on to the next question and I'll come back to you later. Okay. The other question is, can you walk us through the Jenkins build job details for provisioning Docker Swarm and Kubernetes, and how are you building these jobs? Yeah, I think this was already covered during the presentation. Master and worker nodes will be used to manage the same application. Yes, the answer is yes. Okay. How do you deploy applications in Docker cluster?
I would like to answer this. The deploy applications are actually done with the base of service that is going to be used here. See, we got to be like deploying services like Redis as a service, Tomcat as a service, and then it is going to be Nginx as a service. So all these are like going to be the best packages that are required to run an application, deliver it to a customer. So if it is a Tomcat is going to work on a service level, and Tomcat runs the way, and it is going to keep showing up all the, it keeps running the own applications that are required. So yes, master and worker nodes will be used to manage same application, but it will be the master who will be taking all the incoming requests, and at some point, if master not unable to answer, then it will be taking up with, then it will be taking up to the worker nodes to manage to handle the high availability setup. How do you deploy applications in Docker cluster? I think that's the same question what we have answered above. How do you deploy applications? It's all about the service that is going to be used. Okay.
One more comment on the service and deploying applications in the Docker cluster. You need to understand that yes, you can have Redis as a service, as my friend Jaikardi mentioned, but what you need to also know is, when you are actually having your entire application that you are developing, A, you will be splitting it into microservices. B, you will be basically kind of following, and I recommend very strongly, if you're Dockerizing your application, Dockerizing your services, follow the 12-factor app approach. That would kind of that is a recommended approach for deploying applications or services in Docker, and then you will have a very smooth run in production. If your app is not a proper 12-factor app, you need to really think through your entire life cycle and limitations of Docker, or what are things that you need to take care of in production. Okay. Other question is, any comments on drone CI tool to integrate with Kits?
Yeah, any CI tool can be.
Yeah, you can integrate pretty much any CI tool. In fact, Wrecker being more popular than Drone CI, but yeah, Drone CI can also integrate. Okay. Terraform code, is it publicly available on GitHub? Terraform is basically a competition to Ansible. So it's an open source tool, and you can kind of use it, download it and use it for your automation purposes, and so obviously it's available to download for free. So if there is a new version of application file, how would you handle?
I mean, that part is going to be easier when it is going to be coming in as a version part. Then it is going to be an image that is going to be deployed, and it's not a WAR file that we directly take. It's always coming in as a Docker image that will be deployed to the Swarm network. Okay, once it is done, it is going to be the services that will be handling the images to pull in and give the uptime to the end user. Okay.
In a master node configuration, what happens when master node goes down?
Master node will never be going down. I mean, like it's cluster management. Whenever master seems to be like, even with the demo what we gave here, we are actually like bringing in a single master and worker node setup. But in a production line, we'd never be having it up as a single master. So master will be coming it with multiple masters at the bottom level to the second layer, and the third layer will be covered up with the workers. So whenever one master at the second layer goes down, the first layer master is going to alert rest of them that there is one down, and it will always pull in immediate, just like what we showed for Kubernetes. It's a sanity check tool will be running for every node that is being connected in production.
So somebody has asked, how do you take a traditional Hadoop cluster to move into Kubernetes or Swarm cluster? So you cannot, to answer the question, little bit it's out of scope, given this current webinar, we can get back to you on that. But my first comments here is, first of all, you don't move an application to Kubernetes, you move it to Docker and then create pods in Kubernetes to move that, right? So somebody has asked, so I think we'll get back to you on this. We're not prepared to answer this in this particular, regarding Hadoop part, we're not prepared to answer, we'll get back to you. Now somebody has asked, what is 12-factor app? Now that's a very good question. So when you're developing the modern applications, a 12-factor app is a 12 characteristics of an application, and it's a very standard industry term. You can Google it as well. So Heroku is the term is a platform as a service company which kind of introduced this terminology. How you can containerize application, how you can create microservices, what is the the gold standard where if you follow the standard you will get a trouble-free application which are running in production, and such kind of applications are very DevOps friendly. They scale very well. They are containerized or they're put into Docker really well. So these are the benefits that you get. The 12-factor app is nothing but development methodology, rules and practices that you follow to develop your application. Okay. How would you troubleshoot JVM and Java application issues in Docker? So understand one thing, Docker is nothing but a Linux container. If you had attended my first webinar on Docker 101, I would have told you that there is, you would not find any difference or significant difference between running it on a Linux machine and the Linux container. Right? End of the day, Docker basically it's just a sandbox. See, let me reiterate what a container is. Right? A Docker container is just 3 components. Number 1 component is Linux C groups. What Linux C groups does is it gives you capacity to allocate specific memory CPU to a particular sandbox or within a particular process within the entire Linux kernel. Okay. Second part is there is something known as namespaces. Namespaces is something like a chroot in Linux, where you'll be able to kind of give you a very limited view of the operating system, so that you get your own proper sandbox, you get your own memory space, variables, etc., so that you're able to kind of have that environment integrity that a container promises you. And third part is a Docker image. So these are the 3 components. Now, other than that, these Docker containers are completely dependent on the Linux kernel on which they run. So this sandboxed components, they talk to the Linux kernel via syscall, right? So, so pretty much when you deploy an application in that container, what you get is nothing but a complete Linux environment. So you debug Java applications, JVM issues, the way you debug basically Java applications in a normal Linux machine. Okay. Now somebody wanted the Terraform code to be shared. Certainly, we will share that code, and one of the the organizers will get in touch with the entire team. We will share, and also this entire deck presentation with your question and answers, everything will be uploaded to YouTube as well. Okay, and the link will also be shared with you.
So with this, we will end the session today. We have some more questions to be answered, but in the interest of time, we would prefer to respond to this question over an email. So as just Venkat mentioned, we will be sharing the slide deck along with the video, mostly by tomorrow. So kindly provide your feedback on the session, and if you have any questions, feel free to write to us. We will respond to you at the earliest. Thank you so much for joining the webinar.
Yes. Thanks a lot, everybody.
Thanks a lot.